Now you see, in the question, first bit more than 2150. So this is one x value. We have to convert into z value. These two numbers, 1920, 1950, and one more 2160. Four numbers we are going to convert into z values. Very good. That conversion is z is equal to x minus, this is the equation, x minus 2040 by 60. Just you replace x value here, you substitute x value, you will get some z value. So for first bit now, x is equal to 2150. What is z now? 2150 minus 2040 divided by 60, that is equal to 1.833. Now we want the probability that lifetime is more than 2150. That lifetime is greater than or equal to 2150 if z is greater than or equal to 1.833. This number. Following?
Yes, sir.
This number. So we want the area from 1.833 onwards. Now you see here I have not given any line here. Means what?
Infinite.
From z is equal to 1.833 up to infinity. We want all of them, right? Just it is given 2150 greater than 2150 means it may be 3000, it may be 4000, anything more than 2150. So there is no upper limit here.
Yes, sir.
The lower limit is 1.833. So we want probability means area where z is greater than or equal to 1.833. So nice. So what should I do here? I want this complete area.
Yes, sir.
We know the fact that below this curve, above x-axis, the complete area is 1. So what is on the left hand side? It is symmetric. So it is on the left 0.5 and 0.5 on the right hand side. So complete area on the right hand side
Is 0.
0.5. From that, remove the area from 0 to 1.833. If you remove this area,
Yes,
then you will get this area. So what should I now do? You see here, v of z greater than or equal to 1.833 is 0.5 minus from origin to
1.8.
this origin to 1.833. And this from normal tables it is 0.4664. But in the examination, in the question itself, this will be printed. P of z lying between 0 and this one is 0.4664. So just remove, you will get this number. I hope you understood.
Yes, sir.
Now going to the no. The question was how many bulbs are expected. So we have to multiply the probability with total number of bulbs now. The number of bulbs expected to burn for more than 2150 hours is total is 2000 bulbs. The 2000 bulbs into the probability. As we say coin, if a coin is tossed 1/2 for head, 1/2 for tail means 50-50, 0.5. If the coin is tossed 1000 times, what is the total? 1000 times. Then what is the how many times we can expect head? 500. That is 1/2 into 1000. That will become 500. Like that here we are multiplying the total count with the probability. 2000 into 0.0336. That is 67 approximately. Actually it is coming fraction. That fraction will not be number of bulbs. So we are making it to approximately 67. That value will be either 67.1 or it will be 66.9. Which is correct value to round off to 67? Come on, make a guess. 67 is nearest figure.
Yes.
It may be 66.9 or it may be 67.1. Which is correct figure?
66.
No.
Sir, 66.
67 point something means 67 is the base, something more, but that something more is not one bulb, so you will drop it. So the actual answer would have been 67 point something, not 68. Less than 68, more than 67. So that is rounded to 67. Next we want what?
Less than 1950.
1950. That is the next figure. We want x to be number, this probability of x less than or equal to 1950 means left side. So what is the figure? Where is the figure?
Yes, sir.
Yes, I will bring the figure up to here. So is this understood? What is the z value for 1950? What is the Z value for 1950?
1950
minus
1.33. So x is less than or equal to 1950 is nothing but property Z is less than or equal to
minus
1.33. Now that is, I'll show from the figure. See, the figure you have to understand from this situation first of all. We want, one step more is missing in negative.
Yeah.
Yeah, this one. We want Z to be less than or equal to,
Minus 1.3.
means this shaded region. Are you able to understand?
Yes, sir.
And again there is no lower limit. It may go up to minus infinity.
Yes, sir.
So this is Z is equal to minus. But this area is same as on the right hand side,
Less
from
1.33
1.33 to infinity. So what I have written here? Probability of Z greater than or equal to
1.33.
1.33. So 0.5 minus
1 point.
this complete 0.5, no?
Yes, sir.
This complete is 0.5.
0.5.
We want this region.
Yes, sir.
So area of this region is total 0.5 minus from 0 to 1.33.
1.33.
From 0 to 1.33, whatever area is there, you remove it from total 0.5. So is it working same, you see?
Yes, sir.
This greater than or equal to 1.33 is 0 to 1.33. You have to remove from 0.5. So that tabular value will be given in the question.
Yes, sir.
You have to subtract this, you will get it. This is the probability.
Yes,
Now
sir.
how many bulbs are expected to burn for less than 1950 means 2000 you have to
2000
multiply
into
with the probability.
0.09.
So expected number of bulbs to burn for less than 1950 hours is 0.0918 into 2184 approximately.
Yes, sir.
And between 1920 and here, third question,
2160.
between 1920 and 2160.
2160.
So what are the Z values? Minus 2 and
2.
plus 2.
Plus 2.
Just you substitute, you will
Yes,
get that
yes.
values. So from 1920 up to 2160, that is Z lying between minus 2 and plus 2.
Plus 2.
I need from minus 2 up to
Plus 2.
plus 2. What is the idea, you tell me?
1 minus.
No, not 1 minus. The thing is, this area is same as this area, no?
Yes, sir.
So 2 times of this area, no?
Yes, sir.
So in what way I have done, you
2
see?
into P. Okay. So 2 into probability of.
Is it okay?
Yes, sir.
0 to 2.
So
Yes, sir.
minus 2 to plus 2, that is from 0 to 2, you take the area and multiply 2 times.
Into 2. Yes, sir.
Clear?
Yes, sir.
2 into this area. This area is directly available because from origin to this Z is equal to 2
Into
available in the normal tables.
Normal
Just
tables.
you substitute that value, multiply that. Now what I need to do? How many bulbs are expected to burn for
Into
more
2000.
than 1920
Into
and less
2000.
than 2160 hours? That is nothing but 2000 into this. That is approximately 1909 approximately. Shall we move towards 21st question?
Yes, sir.
Okay, fine. No doubt up to here?
Yes, sir.
No doubt. Very good. Here the pattern of the problem is very different. It is not directly giving mean and
Variance.
variance.
Yes, sir.
Mean and standard deviation
Standard
actually.
deviation.
X minus mu by sigma. So if you know that mu and sigma, you can settle the problem very easily. But here it is reverse. What is that reverse? You see, find the mean and standard deviation of the distribution.
Yes.
It is quite opposite question now. We have to find the mean and
Standard deviation.
Yes, sir.
standard deviation. How we will find? You see, let x be the normal.
Random variable.
Actually, normal word missed. X is normal.
Random variable.
Given that,
X is
now you need to see this information. 31% of items are under 45. Means what? Less than 45. X value less than
45.
45. X. That random variable X. Less than 45. How much is the percentage?
31%.
31% means, can I say here
0.31
0.31 is the area?
Yes, sir.
0.31.
31.
Okay, here you see, given that P of X less than 45 is 0.31 means, we will convert into Z in next,
Yes, sir.
okay. What is given? One more?
8%.
8% are over
64.
64. 8% of X value,
X greater than
okay,
64.
X values, more than, how much? 8%. They are how much?
64.
No, not like that. How many are greater than 64? That is
8%.
Means what is the probability of that x value greater than or equal to 64, that is 0.08, not 0.8. 0.8 means it will become 80%.
80%,
So
yes,
this
sir.
is 0.08.
08.
Very good. So I have written, Acha, you saw this side and you answered.
No, sir.
Okay. You did not see that and answered 8%. Very good. So 0.31 and 0.08. Now you see the normal figure using this two. This is given information. We are drawing the
Yes, sir.
figure now. This is 45.
Okay.
This is 60.
6.
Anyone having doubt why 60, why not 60 this side and 45 that side? Any having doubt?
No, sir.
60, 45 will be lesser, 60 will be here more. And some number in between 45 and 60 will be here, which becomes the mean.
Yes, sir. 0.
Mean is something. But when x is mu, z will be 0. So for 45 we don't know, no? So it will be minus z1 because 0 is here.
Yes, sir.
Because 0 is here, it is minus z1 and it is plus z2.
Yes.
So this is minus z1, that is plus
Z2.
z2. Very good. Now let us talk about the probabilities. 0.31. 0.31 is less than 45. Means less than 45. This complete up to infinity, minus infinity, it is 0.31. So 0.31 means how much will it be here? 31% means 19%.
19%.
So 0.19. Up to
0.
this z is equal to 0.
Yes.
So it is 0.08. So
42.
8%, so 42%. That is 0.42.
42.
0.5 is total here.
Yes, sir.
Yes, sir.
0.5 you have to remove 0.08. That will become 0.42. Add it, it will become 0.5. Also this is 0.5.
Yes, sir.
I hope you understood. Right? Next. You may get some doubt. If you get a doubt, you just note it down. What is the page number? And after the end of the explanation, I will give you clarification. So when x is 45, z is how much?
45 minus mu by
45 minus mu by sigma. We don't know mu, we don't know sigma. But we are saying let it be minus z1. As I said, this side z equal to x equal to 45 minus z1 I said. So let us compare this with minus z1. Say when x is 64, z is
64 minus
64 minus mu by sigma. That is some z2. Say this is positive z2, that is minus z1. Get it? Okay, clear. Given that this is 0.19, so z lying between 0 and z1. Actually speaking, this probability from 0 to z1 is how much? Z1 left side, okay. Z1 is left side. What is that probability given? Shall I come back to the figure again if you have a doubt? This probability is given from minus z1 to minus z1. Be careful here. Minus z1 to 0, given that it is 0.19. Actually, it is not given that one. It is given this. Means indirectly it is given, no? Indirectly it is given. So minus z1 to 0. It is given 0.19. That is what I am writing here. You see. Here this line. Where is that line? This line. Minus z1 to 0. It is 0.19. I written given that because that is indirectly given 0.19. Now from minus z1 to 0, it is same like 0 to z1. Instead of taking this side, I am just going that side. 0 to z1. That is how much? 0.19. Now you have to search the normal table and see where the 0.19 for what z value. That z value minus z1 z1 it is coming 0.496 point. What is that point for which this area is 0.19? Are you getting the point?
Yes, sir.
Probability value is given. We are finding z value now. That z1 is 0.496. So what is the left side point? Minus 0.496. Okay.
Sir, the Taylor value in
Question it will be mentioned.
The tabular value will be mentioned. Be clear about that. It will be given in that, right? Next. Also we get
Z2.
Z2. From 0 to Z2, just a simple point. If I remove Z2 and I write 2.59, are you getting some area?
Yes, sir.
Yes, sir.
Now area is given. You are reversely calculating this. Means for what Z value, you are getting this much of area.
Yes, sir.
So Z2 is how much?
1.405.
1.405. Substituting these values, what were the equations actually earlier we have done?
Yes, sir.
This one, no?
Yes, sir.
45 minus mu by sigma is minus Z1. 64 minus mu by sigma is
Z2.
Z2.
Z2. This is minus Z1, this is minus Z2. Now we got the value of Z1 or not?
Yes, sir.
Yes, sir.
We got the value of
Yes, sir.
Z2.
Z2. You substitute that Z1 and Z2, then sigma comes this side.
Yes, sir.
Yes, sir.
So 45 minus mu will be something into sigma.
Yes, sir.
Similarly, if you substitute,
Z2.
where?
Z2.
Sorry, here. 64 minus mu by sigma. You substitute Z2 value. That sigma comes here, Z2
Yes, sir.
with the sigma. So 64 minus mu is some times of
Sigma.
sigma. That times is available, Z2 is available. Now, substituting in that 1 and
2.
substituting in 1 and 2, we get two equations, you see here.
Yes, sir.
Substituting the value of Z1 and
Z2.
Z2. In equation 1 and 2, we get 45 minus mu this much, 64 minus mu is this much. Now, if you just subtract,
Yes, sir.
okay, if you just subtract, this will become minus mu plus mu, this gets cancelled, you will get some value here,
Yes, sir.
simplifying, and then again writing mu value.
And sigma.
No, first sigma value will come,
Yes, sir.
because cancelling this mu, sigma will come. Substitute that sigma, then mu will come. Either use first equation or second equation. Solving we get,
U and
solving we get
Mu and
mu is 0.4996 and
And
sigma
sigma
equal to 10 approximately. So tell me now whether you understood this.
Yes, sir.
Yes, sir.
Any doubt? You can see the video again. You can play the video and then where you are stuck you can again watch that point. I have explained it completely that one. I hope you have
Yes, sir.
clear
Understood.
understanding.
Yes, sir.
Yes, sir.